Hello, Professor and classmates. Before I begin, I just wanted to wish everyone a Merry Christmas and hope you had a happy Thanksgiving. My name is Nathaniel Collins, and today we'll be discussing the pressurization system of the CRJ-200. The pressurization system of the CRJ-200 is normally controlled automatically, but it can also be controlled manually, and these would be done in circumstances of either a maintenance issue related to the pressurization system, the automatic, or an emergency. The cabin air is conditioned by two cabin pressure controllers, which regulate the amount of pressure within the cabin. And the excess air within the cabin is then discharged through two outflow safety valves located in the aft pressure bulkhead of the airplane. At the maximum differential of 8.6 psi, the cabin altitude is held at 8,000 feet, while at the CRJ surface ceiling of flight level 410. The cargo bin is also pressurized and equipped with conditioned recirculated air. So what components make up the pressurization system? In these next few slides, we're going to discuss the major components of the pressurization system, and they are as follows: the two pressure controllers that we discussed, two outflow safety valves, a cabin pressure acquisition module, and a cabin pressure control panel. And this is located on the overhead panel in the flight deck. So let's begin with the cabin pressure controllers. The cabin pressure controllers control the pressure in the cabin in relation with the aircraft altitude. Only one is active at a time, and if that single pressure controller fails, the system automatically selects the standby pressure controller. There's two identical controllers, and by selecting the press controller button twice, it selects the other source if the pilot desires that. In case of both controllers failing, the pilot can operate in manual mode to control the pressurization system. And these cabin pressure controllers interface with each other and the following systems: the ICAS DCU, the ADC, the PSEU, and the thrust levers. So we'll begin discussing here the outflow and safety valves and our next component of the pressurization system. These outflow safety valves discharge the excess air overboard. The outflow valves are electronically and pneumatically controlled. Pneumatically controlled by the 10th stage bleed air, which creates a vacuum that opens and closes the outflow valve via a jet pump, which regulates the amount of pressure in the cabin. And if one outflow valve fails, the other takes over the entire pressurization system. So this, on the left side here, this is just a diagram showing the many components of the outflow valve and the safety valves. And again, their purpose is really just to allow the air to bleed out of the cabin to maintain a proper and comfortable cabin pressure for the occupants. And this cabin pressure acquisition module is the next component of the pressurization system, also known as CPAM. And what this does is it generates the cabin altitude rate of change, calculates the differential pressure indications displayed on the ICAS. Unique feature about this is it automatically deploys the passenger oxygen mask when the cabin altitude reaches 14,000 feet, so the crew would not have to do that with this module operative. However, if the CPAM does fail, the standby pressure controller takes over. And however, the oxygen mask will not auto-deploy, and nor will the signs illuminate with the CPAM failure. Here's our cabin pressure control panel, which again was located in the overhead panel. On the right side here, you can see the switches and buttons and knobs that we'll be going over here in just a moment. And again, it's in the CRJ-200 pressurization system, in its normal mode, the pressurization system is fully automatic. So the only thing the pilot really needs to do prior to their departure is to select the landing field elevation and the LTG LEV rotary knob over here and you can see that one on the top here, the landing elevation. So the pilot would select the landing elevation of the arrival airport, and then the pressurization controller the pressurization system would do the rest as far as when it's in flight and landing. In the automatic mode, the cabin altitude rate of change is limited to 500 feet per minute while ascending and 300 feet per minute while descending. However, if the automatic mode is unusable, the pilot can switch to the manual mode, which is on the right side of the pressure control panel over here. And in that way, the landing elevation can be selected in the man-out switch, and the manual rate of change, which is the basically the climbing and descending feet per minute rate of change of the cabin pressure, can be selected here. And in that case, it is now limited to, in the manual mode, to 150 feet per minute to 3,000 feet per minute, while the landing elevation is limited to negative 1,500 feet. This is a picture of the ICAS, the Environmental Control System pressurization page. And I just wanted to show you how this is set up and just kind of present a legend to explain what these different abbreviations mean here. So on this, you can see that from the 10th stage, bleed air from the engines that go into the Pack 2. This is more or less for the environmental control system. But however, if you look down below, there is some important information regarding the pressurization system. Here we have our CPAM, which is that module that we were discussing earlier, and then the pressure controller, and this says number 2. So again, we said that there was a pressure controller 1 and 2. So right now, pressure controller 2 is selected on this aircraft. So down here on the left side, we have the C out, which we can reference under the CPAM, is just cabin altitude. Rate defines the rate in feet per minute. The delta P you have there is differential pressure, so it can indicate the differential pressure on this page. And then we have the landing elevation so that the pilots can verify that the correct landing elevation is set. And then the other miscellaneous, just feet per minute, and PSI, pounds per square inch. On this next page, I thought was pretty important and interesting to know. This is how the pressurization system works during different phases of flight. And so I'm just going to go through these, explaining what happens when the pressurization is in different phases of the flight. So ground, we have the outflow valves are positioned open to prevent any pressurization, and one of the triggers of this is the weight on wheels. So this allows the cabin to be depressurized on the ground in case there was an evacuation that was necessary, that you didn't want to blow out one of the doors or windows when we're trying to escape from possible emergency on the ground that would require that. The takeoff roll, when takeoff power is set, the cabin pressurizes to 100 feet below the elevation of the airport. And if an abort is necessary, the cabin depressurizes at 500 feet per minute for 20 seconds, and the outflow valves are positioned open. Again, that's another safety feature for an evacuation. During takeoff, when the aircraft reaches 6,000 feet or less above the airport elevation, and this is for less than 10 minutes, then initiates a descent of 1,000 feet per minute or more, the pressurized system automatically sets the departure airport landing elevation. And this is so the crew does not have to do that in case they had an engine fire or they need to get back on the ground immediately. It's just one less thing for the crew to do. So this is where the automatic part of the system comes into play. And lastly, we have the last kind of sections of the phases of the flight, which we have climb, cruise, descent, and landing. The climb cruise is pretty much the simple part of it, which is the pressure is automatically maintained in accordance with cabin altitude versus aircraft altitude. So if you go up and down, the altitude of the cabin is going to adjust depending on what climbing altitude you're going to or descending. The descent, the cabin descends at a rate of 300 feet per minute to the landing elevation or maximum pressure differential. And then landing, the cabin decreases below the field elevation and then increases 500 feet per minute for 60 seconds. And then, of course, on the ground, the outflow valves will then remain open. So in review, the system is fully automatic of the pressurization system. We have the limitations here of the 8.6 PSI at flight level 410, which the cabin should hold 8,000 feet. The pilot can select the landing field elevation in the LDG LF switch prior to departure. Outflow valves are controlled pneumatically by the 10th stage bleed air, and they're also controlled electronically. And the cabin pressure controllers control the pressure in the cabin in relation with aircraft altitude. And lastly, the cabin pressure acquisition module, which we talked about, the CPAM, adjusts the rate of change, calculates the differential pressure, and automatically deploys oxygen mask if the cabin altitude reaches 14,000 feet. This last page is just my sources of what I've used. And I hope that you've learned some valuable information about the pressurization system like I did during this research. And thank you for your time. Once again, Merry Christmas.